Hello everyone, we are from Group 3 going to present the instrumentation project. So first of all, we will go through the mechanical equipment. So the first one is the measuring tank, which is its function is to measure the liquid volume passing through it. Second is the bubble cap tray column, which is to facilitate the continuous contact between the rising vapor and the returning liquids. Third is the stripping column, which is to remove one or more component from a liquid stream by a vapor stream. Fourth is the plate heat exchanger, which is to transfer the heat between two fluids. Fifth is the straight tube heat exchanger, which is used when viscous and contaminated media is used or where a fast heat transfer without pressure loss is necessary. Sixth is the cartridge filter, which is used for the purpose of clarification. So here are the other list of the mechanical equipment in the PNID diagram. Next, move on to the instrument. So basically, there are 6 instruments in the PNID diagram, which are pressure indicator, flow indicator, level indicator, temperature indicator and controller, level indicator and controller, and the last one is flow indicator and controller. Next is the control valve. There are 2 control valves. So the first one is the piston valve, which is to control the motion of a fluid along a tube or pipe. Second is the pneumatic valve, which is to control or manipulate flow of the fluids. Next is the bubble. So basically there are 2 bubbles in the PNID diagram, which are field mounted and control room. And the last one is the transmission line. So basically there are 5 lines in the PNID diagram, which are flange, straight line, pipe, process connection, electric signal, and the last one is connection line. So you guys can go through the function of each of the line here in the slide. So that's all from me. Thank you.
Assalamualaikum, my name is Muhammad Zulkifli and I will talk about this loop 1 in this instrumentation project. The control objective of this loop is to control temperature oil the leaving heat exchanger, the stream, and the control configuration is feedback. And the control and measured variable is temperature of oil that leaving heat exchanger, also the stream. And the what we manipulated is flow rate of feed steam, this. The disturbance is the temperature of feed oil from heat exchanger, this stream. Segregation of sensor, there are two type, type J thermocouple and resistant temperature detector, but we choose resistant temperature detector as our most suitable sensor because it's most accurate and reliable method to measure temperature, and the temperature is also similar to our pen ID description. And the most suitable valve we choose gate valve because it's suitable to use in high temperature and pressure condition, and also provide laminar flow and pressure loss is minimum. This is loop 2. The control objective of this loop is to control flow rate of feed steam that enter the deodorizer. The control configuration is feedback, and the control and measured variable is flow rate of feed steam that enter the deodorizer, the stream. What we manipulated also the flow rate of feed steam that enter the deodorizer, and there are no disturbance in this loop. The suggestion of sensor is vortex meter and orifice restriction flow sensor, but we choose vortex meter as most suitable sensor because it causes minimal pressure drop and they can handle high pressure and temperature. Also, vortex meter offer wide range ability which enables the measure of steam flow at varying velocity. And the most suitable valve we choose gap valve because it's suitable to use in high temperature and pressure condition. They also provide laminar flow and the pressure loss is minimum. Thank you. So,
Assalamualaikum warahmatullahi wabarakatuh and very good morning to everyone. So today I'm going to talk about loop 3. So here is the diagram for the loop 3. So the control objective is to control the temperature of the outlet stream of the heat exchanger. And the control configuration is feedback loop control. The control variable is the temperature. The measured variable is also the temperature of the outlet stream. So the same one. The manipulated variable is the flow rate of the cooling water. The disturbance is the temperature of the cooling water. So there are 3 suggestions: the thermocouple, RTD, and thermistor. So the most suitable sensor is thermocouple. this is the justification for why thermocouple is the best. So for the valve, for the control valve, there are three type: control valve, ball valve, gate valve, and plug valve. So the most suitable valve is the plug valve. So here is the justification why plug valve is the best. So here is the diagram for the thermocouple and plug valve. So look for the control objective. Here is the picture of the look for control objective is to control the heater oil in the pre-stripper. So the control configuration is feedback control. The control variable is the heated oil level, so the level, and and the measured variable is the heated oil level. It's also the same, and the manipulated variable is the flow rate of oil leaving the stripper. So here at the valve. So the disturbance is the inlet stream of flow rate entering the stripper. So there are three types of sensor that we can use. The first one is capacitance, hydrostatic, and nucleonic. So the most suitable sensor is the nucleic level sensor. So this is the justification for nucleic level sensor. Uh, and the valve, control valve used in the loop is the gate valve and the globe valve. So the most suitable valve is the globe valve. So here is the justification why globe valve is the best. So at the right is the picture of the globe valve. Thank you very much, and I will proceed with another presenter.
Hello, I'm Dharani Sundaramurthy. I will be presenting Loop 5 of this instrumentation project. So this is the loop 5 that we labeled, and the control objective of this loop is to control the temperature of the outlet stream from the heat exchanger which enters 2FL741A over B. So this loop is a feedback loop where it can control the outlet temperature by manipulating the flow rate of the inlet stream. So the control variable is the temperature of the outlet stream from the heat exchanger which enters 2FL741A over B, and our measuring variable is also the temperature of this outer stream. We manipulating the inlet of the inlet flow rate of the cooling water, and the disturbance in this system we identify phi as the temperature of the inlet stream which from 2 heat exchanger 711 which enters 2 heat exchanger 742. So next we will moving on to sensors. So we suggest type J thermocouple and nickel resistant temperature detector RTD. The most suitable sensors that we found out is nickel resistance temperature RTD is because it has a good thermal contact in liquid bath, cheaper and more sensitive with a smaller temperature range, and it is suitable for controlling temperature between 50 degrees Celsius to 55 degrees Celsius. Next, moving on to the valve. We suggest gate valve and butterfly valve. But then we choose butterfly valve because it can control the flow of cooling water which enters the heat exchanger. It also able to accurately throttle the flow. Thanks for watching, and that's all from us from Group 3.